Okay, so Chapter 1, Day 3. This is the last lesson for Chapter 1. It's going to be a little bit of something you did from 9th grade or Algebra 1, and a little bit of something new. So what we're going to focus on today is how do we solve quadratic. Remember, quadratic is any kind of x squared question. How do we solve quadratic equations and inequalities by factoring? You have solved quadratic equations by factoring, so that's not new, but we're refresher. And then the inequalities will be the newer piece for today. It's going to look very similar. There's just an extra step that we take for inequalities. So the problem might start out solve for x and check. Okay, so here's the problem. It doesn't look like a quadratic because I don't see x squared, but there's some work here that I could do first. Does it mean we always distribute first? No, but we need to get the problem simplified first. And the first thing we need to do as well is we've got to get the equation equal to 0. So if you remember back to when you did Algebra 1, you have to get that equal to 0 in order to solve. So first thing we're going to do is do a little bit of math to get it equal to 0. But I'm going to go ahead and distribute. So x times 2x is 2x squared. X times a negative 7 is a negative 7x or minus 7x. And that is still equal to negative 6. Still not equal to 0 yet. So let me add 6 to both sides. And I have 2x squared minus 7x plus 6 equals 0. So it now definitely looks like a quadratic because it has an x squared. It is now equal to 0. And so whenever we see an equation, and it's an equation because of the equal sign, and a quadratic, we know that we're going to have to now take step 2, which is to factor. But after you factor, remember it's an equation, you still have to keep it equal to 0. So factor and keep the equation equal to 0. Well, I'm going to look for a GCF. 2, 7, and 6. No GCF. Are there x everywhere? No. Oh, how do we factor when the leading number is bigger than 1? We just did it last lesson, which is the AC method. So, got to go through the AC method. So I got 2 and 6. 2 and 6 combined to give me 12. Now, even before I think of the 7, I want factors of 12. So 1 and 12, 2 and 6, 3 and 4. Okay? I want factors of 12 now that add to 7. I don't care if it's positive or negative yet. I just want them to add up to 7. 3 and 4 do. Okay, so here we go. 2x squared. Now, using the 3 and 4, I have to get a negative 7. So minus 3x minus 4x. It does not matter what order you write these in. You'll always get the same answer. Okay? Plus 6 equals 0. Remember, with the AC method, the first piece and the last piece remain the same. It's just this middle piece that we're using these two factors to make up. All right? Now, brackets. Okay? We're going to AC factor a lot this year, so if you are struggling with the AC method for factoring, please come in, get a little bit extra help. So we're still factoring, so we're still on step 2. So let's keep going with step 2. Take out a GCF. The only thing I see here that I can take out is an x, and I have a 2x minus 3 left over. Over here, it looks like I can take out a 2, but notice this is a minus, and this is a plus. There's no way that this parenthesis can have a minus in it if I take out a positive number. So I'm going to take out a negative 2. So I got minus 2 here. And now I'll have a 2x, because negative divided by negative turns that to positive, minus 3, and lo and behold, they now agree, still equal to 0. I cannot forget to keep that equal to 0, otherwise I've created, from an equation, an expression. I have to keep it as an equation. You have to have this the whole way, or on the Regents exam you do not get full credit. Well, one last step. 2x minus 3 is common, so that gets its own parenthesis. X minus 2 are the pieces out in front. Still equal to 0. Okay, So we have now done step 2, factor, keep it equal to 0. Set each factor equal to 0. So if you remember from Algebra 1, sometimes teachers called it a T chart, okay, because it looks like a T. I don't care how many factors you have to make a column for each one of those to go into. So if there's 2 of them, it looks like a T. Set each factor now equal to 0. And solve each for x, step 4. Solve each of these for x. So add 3. So I have 2x equals 3, divide by 2, x equals 3 halves. Now I know what you're thinking. That can't be an answer because it's a fraction. Yes, it can be. In Algebra 2 Trig, many answers will come out as fractions, and that's perfectly fine. It's not a bad number, 3 halves, it's 1 1/2. It's perfectly okay for that to happen. Add 2, x equals 2. So my 2 answers are x equals 3 halves, x equals 2, and if I wanted to check them, okay, I could put them back into the original equation. So sometimes it will say check your answer. And so let's go through a check real quick. Let's try 3 halves. So my original problem was x, parentheses 2x minus 7 equals -6. Put in 3 halves. So I have 3 halves times 2 times 3 halves minus 7 equals -6. Well, if you remember a little bit about multiplying fractions, this is really like 2 over 1. So these 2's reduce. 3 take away 7, that's -4. And 3 over 2 times -4. Well, 2 and -4 reduce down to a -2. 3 times a -2 is a -6. That equals -6. Check. Let's try the other one. Plug in a 2. So I have 2, parentheses 2 times 2, take away 7. I'm out of room, but that's okay. Equals -6. So 2, parentheses 2 times 2 is 4, minus 7 is -3. And I'm trying to see if that equals -6. 2 times -3 is -6. That equals -6. Checks. So those are good answers. Box them in. If they do not check, if these answers did not check out, I'm going to say one thing, double check your work. If they do not check, then you would reject one of the answers. Okay? If you make a mistake somewhere and you can't figure it out, your answers might not check. You have to reject them. You can't box them in. So if they don't check and you reject them, you would only lose a small amount of credit for wherever your mistake was. Well, that is solving quadratic equations because there's an equal sign. Same process used in Algebra 1. Now, quadratic inequalities is what we're going to look at next. So, solve and graph. Inequalities, we graph on a number line. Okay? So here we are. Now we have an inequality. And it's a quadratic because it's an x squared. So first thing is to get the equation equal to 0. Even though this isn't an equal sign, you got to make sure 0's on one side, number's on the other. Luckily enough, we have that. Next thing we're going to do is factor like it's an equals problem, not an inequality. Just factor it like it's a regular equals problem. Okay? So ignore this side. Let's factor. Ooh, I see a GCF I can take out first. So I'm going to take out a 2. Okay? Take out a 2. I'm going to divide both sides by 2. Just get rid of that. So I have x squared minus x minus 12 less than or equal to 0. Made my life a lot easier. Will you always take out a GCF? No. But you have to just go through the process of factoring. Look for GCF. If there is one, take it out. If not, we might be doing AC method on something like that. Here's the good news. If you do not see that a GCF, the AC method will still work. It just, you're working with a lot number like 48. All right, so keep factoring because I'm not done. I haven't factored completely yet. So I want factors of 12 with a difference of 1. So factors of 12, 1 and 12, 2 and 6, 3 and 4. 3 and 4 differ by 1 with a difference of 1. Forget that it's negative, they just have to differ by 1. We'll deal with the negative in a minute. So 3 and 4, it doesn't matter where you put them. Now I need a negative. And that negative on the B term goes to the bigger number. Negative 4, add 3 to get to negative 1. And still factoring like it's equal to 0. So I'm going to change that symbol, equal to 0. I'm going to factor like it's equal to 0. Now, step number 3, find the zeros, which is set each factor equal to 0 and solve. You're finding the zeros when you do that. Getting each factor equal to 0 and solve. Go make your t. X plus 3 equals 0. X minus 4 equals 0. So x equals negative 3, just subtracting 3 from both sides. X equals 4, adding 4 to both sides. We're not done because this originally was an inequality. Okay? So, step 4. Graph the zeros and test a point in between them. You have to test a point out to see if it works or not. So graph my zeros, graph the zeros and test a point in between them. So here's my number line. I have a negative 3, positive 4. I look at my original problem. Notice the equal to symbol is there. So I'm going to fill in. But now I'm going to test a point. A convenient number between any negative and positive number is 0. It's always there. And I'm going to try 0. And if 0 works, I'm going to graph where 0 is, which is between them. And if 0 does not work, I'm going to graph away from where 0 is. So you're going to test a point in between. If the point works, then shade between, or I guess draw a line between, right? If the point works, then your answer looks like that. If the point doesn't work, okay, if that point doesn't work, then your answer looks like this. Because what's between them does not work, you would not shade there, so you must be shading away. So if the point that you test works, you're between. If it doesn't work, you're away. So you pick a point. I'm going to pick 0. So I go back up to my original question, 2x squared minus 2x minus 24. So here's my test. I'm going to test 0. So I have 2x squared minus 2x minus 24. And I want to know if that's less than or equal to 0. This is my question. Is this true? I'm testing this. I'm going to test out 0. So I'm going to take 2 times 0 squared minus 2 times 0 minus 24, and I'm trying to see if that is less than or equal to 0. Well, 0 squared is 0 times 2 is 0. Minus 2 times 0 is 0, minus 24. Well, nothing minus 24 is a negative 24. Is that less than 0? Yeah, negative anything is less than 0, so yes. So my answer then is, again, here's my number line. Here's -3, here's +4. My solution then is, well, if the point works, I'm going to go between them, because that's where I tried it, and there's my solution. And that's graphing inequalities, quadratic inequalities. There's your solutions. Any of these points will work. And so when we come to class, we're going to try out some of those.